Oh, I didn't see you there. I heard you were doing polymer examples.
Oh yeah, polymers! Monomers connected to each other. Balloons, silly putty. Thank you, thank you.
Brought to you by the Balloon Popping Band. We make music by popping different sized balloons to make different notes. Hire us for your next party and we'll pop the roof off.
Have you ever played with balloons? Balloons are everywhere! And you know what the best part of balloons are? Science!
Science!
Is that the balloon of science?
Yeah, it's the balloon of science. And here, we got the skewer of science, too.
What are you gonna do with them?
We're gonna stick this through the balloon. But first, you have to lubricate your skewer using some Vaseline. Just rub it on. You wanna aim over here on the edge and use a kind of twisting motion. Kind of go through the balloon. And then just stick it all the way through. There we go. Balloon on a skewer. So why does this work? Well, a balloon is like a net of polymers, and these polymers are all interconnected using crosslinks. If you try to stick a skewer through here, the strength of the crosslinks is too weak since the net is like stretched out. So once you poke it through, it will just break the bonds, and they won't be able to hold the balloon together. But if you stick it through somewhere like here, where there's more rubber, the crosslinks are able to open up and surround the skewer to allow the skewer to go through the balloon, but still remain bonded with each other. So that's what keeps the balloon intact without popping. But if you stick it through here,
In the demo, the Vaseline on the skewer glues itself to the balloon and creates more friction. Is that true or false?
I think that's true.
Wrong! The Vaseline lubricates and seals the skewer, and that provides less friction.
The more you know.
balloons are an elastomer. When polymers are cross-linked, individual chains become a large molecule.
Did you know that humans exhale 3,456 liters of CO2 a day? And CO2 is not your average garbage gas. It contains carbon, which is a very important element that can be found in everyday life. So take this rock, for example, and it probably has carbon in its structure too. It not only is it made out of carbon and other elements, but the molecular structures that contain carbon are known as carbon structures. So please, consider the following. There are many different types of carbon structures that look completely different, one of which is amorphous. These amorphous solids have a rigid structure and do not have a definite molecular pattern. Another example of a carbon structure is graphite, which is made up of a hexagonal structure that is formed in layers, known as lattice. Another example of a carbon structure is a diamond, which has a pyramidal structure and as a result is very dense, which causes it to be extremely strong, allowing it to penetrate different objects. Other than carbon structures, there are also molecular structures that are bonded with bonds that have varying strengths. One of the examples of molecular structures is silly putty.
What is silly putty? Well, it's a real solid liquid.
Silly putty is a combination of silicone polymers, boron atoms, and a hydroxyl group, where the silicone polymers are covalently cross-linked, and the boron and hydroxyl groups are bonded by a hydrogen bond. And this is an example of a molecular structure. Thank you for watching. Consider the following.
Dad, why is bread so edible? Well, son, bread is made of gluten, and gluten is a polymer. Oh, Dad, what is crust made out of? I have no idea. Dad, what now? Why is everything black and white? Shut up. Silly putty is a very cool substance. You can do lots of things with it. You can stretch it. You can roll it into a ball and bounce it. Now, the funny thing about silly putty is that when you hit it with a hammer, it will not change form, it will simply bounce. But if you slowly press down on it with your thumb, it will slowly deform into a squished shape. So let's first roll this into a perfect ball because it needs to be perfect. So, there. Observe. It doesn't change shape. But if I slowly press down on my thumb, it flattens out. Why is that? Silly putty is a silicone polymer, and depending on how you treat it, it can act as a fluid or a solid, hence making it a non-Newtonian fluid or a viscoelastic fluid. This behavior is due to its long stringy molecules. You can think of them as mian. If you strike the silly putty sharply and quickly with a hammer, it does not give the entangled molecules enough time to react, and the silly putty simply shatters. But if you exert a slow force on it, it gives the molecules enough time to adapt to its new shape. Therefore, slowly mold whatever you want. The thumb is mightier than the hammer.
Hammer.
The thumb is mightier than the hammer.
Silly putty can also shatter like rocks. So take a hammer and silly putty
And smash it. Okay. And smash it.
Like the demo prior, the silly putty didn't have enough time for its long, stringy molecules to react to the sudden sharp blow from the hammer. As a result, it just showed its solid properties and shattered.
And remember, nothing else is silly putty.
Creep. A viscoelastic characteristic of a solid material to deform permanently under lots of stress.
Order.
jury has come to their conclusion.
As a jury, we found Mono Tony and Mono Justin guilty of cross-linking.
As a punishment, you are sentenced to the following inabilities. You cannot flow when heated, you cannot ever be separated, you cannot dissolve in solvents, and you cannot be molded or shaped. Case closed.
Sail, sail, sail.
Are you tired of normal balloons at parties? Well, guess what? I have a new product in store for you. Balloon on a stick. This will intrigue your party guests, and they'll always wonder, how do you get this stick through the balloon? And you know what? It's all because of its magnificent elasticity.
For even more viscoelastic fun, limited time offer comes with a free silly putty on a stick. Viscoelastic fun. Fun for everyone.
It's time for the Were You Paying Attention quiz.
That's our show. Thanks for joining me in our discussion of polymers and their characteristics. Gotta go. Some viscoelastic material here.
Produced in association with the National Science Foundation.